Hello, welcome to GS Digital Intervention Program for Senior High Schools. This is Mathematics Lesson 8 on investigating Pythagoras Theorem and applying Geometry 1. Your facilitator is Professor Christopher Oti. I will start with activity that will motivate the students. So I want you to take 6 sticks. We are going to use 3 of the sticks to form a right angle triangle. So in this case, you are going to form 2 right angle triangles of different lengths. So I'm demonstrating this with the broomsticks here. So you can have this crossing at this point. So we are having 90 degrees here, and this will be in this form. So form a right angle triangle with these 3 sticks. We can form another one here too in this form. So we are having this also formed, and I think the students can easily do that. Now when we have this, we may expect that the students will have this on the board or on the screen. So this is the activity there, and then they will now take the trouble to measure the size. We have size A, B, C. Now we have the slanted side, which we call the hypotenuse, and the students are going to measure, and then we move on. So do your measurement, and then we see what you will get. All right. Now look at the learning outcome. We'll be able to investigate the Pythagoras theorem and explore its applications. Our outline for this is investigation of Pythagoras triples of right angle triangle, still under plane geometry 1. Our keywords, we have right angle triangle, perpendicular lines, hypotenuse, Pythagorean triples. So we start with our work now. We are investigating lengths of sides of right angle triangle. Now draw 3 right angle triangle with different sizes and measure the size of each triangle. So we can see the drawing over there, and we can see this on the geoboard as well. Here I've shown 2 on the geoboard, and then you have to measure each of them, and then we can see how it will be. I'll be measuring mine, and I'm measuring the first one. I'm getting this side to be 12, and the other side here, I'm getting it to be 16, and then the other side here, I'm getting it to be 20. So what about yours? What are you getting? Do the same, and then we shall compare the size. The 2 sides that form the right angle, and then that of the hypotenuse. We shall compare that. I hope you have done that, and then you will draw a conclusion out of it. Now we extend it to a practical session of this, that we have a right angle triangle with size 3, 4, 5. The 5 is the hypotenuse. The side 3 and 4 form the right angle. Now we want to investigate this. So where we have the 3, we create an area to form that. So 3 spaces of length and 3 spaces of width, meaning we are going to get 9 spaces in square A. And then we come to square B, where we have 4. We have 4, length 4, so we get width also 4 to become a square. So we have unit area over there to be 16. Then we do that of 5 also. So we create 5 square, length 5, width 5, and then we get 25 over there. Now we go on to compare these areas and see what will be the relationship. So we have this. Area A, we have 9. Area B, we have 16. Area C, we have 25. Now discuss with your colleague or friend to show the relationship among these areas. What do you think will be the relationship? You have 9, 16, and 25. Can anybody tell me? Among the three. Yes. Your guess is perfect. We are having 9 plus 16 equal to 25. So that is the relationship you are getting as I asked you to do. Compare it with what we have here. So we are having this as 9 plus 16 equal to 25. Each of them is a perfect square number. So 9 will be 3 squared, 16 will be 4 squared, and 25 will be 5 squared. The 3, 4, 5 are the initial size of the right angle triangle we started with. So comparing with right angle triangle below, you notice that the side A squared plus B squared is equal to C squared, which is the hypotenuse. Now, dear friends, can you now see the relationship among these numbers or the size of the triangle, right angle triangle? Now, can you state wherever you are, try and state the Pythagoras theorem, because it's based on these sides, the 3 sides of the right angle triangle. Now, you are stating, so I'm just helping you in this sense, that in the right angle triangle above, we can say that the Pythagoras theorem is A squared plus B squared equal to C squared. So when we employ subject of formula, we can find A to be square root of C squared minus B squared, finding one of the sides. B also, we can find square root. B is square root of C squared minus A squared. And then C, which is the hypotenuse, is square root of A squared plus B squared. Now our numbers A, B, C, which are the initial size of the right angle triangle, is called Pythagorean triples. So if you have these 3 numbers and it's a Pythagorean triple, then it should be able to satisfy the Pythagoras rule, which is A squared plus B squared equal to C squared. Now let's take example from this. You have a right angle triangle. One side is 16, the other side is 12 centimeters. They form the right angle triangle. So find the value of x, which is the hypotenuse. So our solution will simply be this. We are looking for x. So it is 12 squared plus 16 squared. And 12 squared is 144 plus 16 squared, which is 256. And this will give us 400. So x is square root of 400, which is equal to 20 centimeters. So be able to use the Pythagoras theorem to find this length, which is the hypotenuse. Let's see the next example. Here the hypotenuse is given and one other side is given. So you have to find the second side that helps to form the right angle triangle. Dear student, this assignment is for you to use the Pythagoras theorem to fill the places omitted. Then you have square root of 25 squared minus 7 squared, and then you get the value of b from the Pythagoras theorem. The second space, a, is omitted, so you can find it the same by finding 17 squared minus 15 squared, or square root will give you the value of a omitted. The third space, we have b omitted. You can use this same concept to find it. Then the fourth space, c, is omitted. So you have the two sides which form the right angle triangle, and then you can find it to be 20 squared plus 21 squared, or square root, and will give you the value of C. So you can do this to find the other spaces, and I believe it will be something that you can do at home. You can now take a picture of this assignment and do it at wherever you are, either at home or in school. Practice it, and then you'll be used to it. We move on to the next one. Next assignment, take a picture of this one too. This one is a little bit algebraic because you are not seeing the numbers, but indirectly giving you algebraic form of getting the Pythagoras triples. So you have m squared minus 1, comma, 2m, then the third one is m squared plus 1, where m is greater or equal to 2. So if you substitute 2 in m, first one you get a 4 minus 1, which is 3. The second one you get 2 times 2, which is 4. And the third one you get 2 squared, which is 4 plus 1. So this will generate 3, 4, 5, which is a Pythagorean triple. And this is what I want you to look at it carefully. Although you have seen the formula in terms of the side, we can now write that also in this form. So in this case, from the diagram we had, m squared minus 1 is equal to A, and 2m is equal to B, and then m squared plus 1 is equal to C. This is another way you can see it applying algebra. Now there is another notation which we can also apply here. Here we are using two variables, m and n. So our Pythagorean triple can also be represented in this form by algebra. M squared minus n squared. The second will be 2mn. And the third will be m squared plus n squared. Note the condition. M minus n is equal to 1. So the two numbers you are taking, this is the difference. And you have to apply that one very well. So if you take any number in this sense, make sure that the two numbers, their difference is 1. For instance, if we take 3, then our n should be 2, so that the difference will be 1. So we put 3 and 2 in our work, where m is 3 and then n is 2. So we shall have first one to be 9, and then the 2 squared will be 4, and then we subtract and get 5. Then this one will be 2 times 3, which is 6, times 2, which is 12. And then this one we shall get 3 squared, which is 9, plus 2 squared, which is 6. So that will give us 15. So from here, we'll be able to generate another triples, which is giving us 5, 12, and 16. So this is how you can generate all of them. And this will give you a formula that you can generate uncountable number of triples. So if I ask you that out of this, generate 20 Pythagorean triples, you'll be able to use this formula to generate. The first one we had ABC, you have to calculate before you can get the triples to be equal. But here, you have been given the rule which you can use to generate all triples based upon the conditions given. Thank you, dear student. I hope you have learned something from this. Apart from learning how to use the numbers on the right angle triangle, you've learned also about how to generate the Pythagorean triples from the rules given. Now we can see its applications in many forms, and then we can look at it in that form. For instance, in the room, the example we gave in the room, you'll be able to find the diagonal of your room. You may be able to find the diagonal of your exercise book, and then other activities can be useful. Hope to meet you in the next lesson, where we shall investigate properties of quadrilaterals. Thank you, and bye-bye.